Hi, everybody. Welcome to the Kokkos 5.2 release briefing. Let's get started. Conrad, next slide, please. All right, so the outline for today, I'm going to open with a few organizational announcements, and then we're going to go over the main feature highlights and go over the details of all the things that have changed. One thing that's new compared to previous release briefing is you'll see we actually had a release of Kokkos tools, and we'll briefly talk about the initial release, and then we'll change over to the Kokkos kernel release highlights. So as usual, all our resources you can find on our website, kokkos.org. If you haven't done so already, you can register to our mailing list where we do announcements such as when we create the release candidate branches or for announcing events and whatnot. If you're not already on Slack, you can also find us on the community tab on our website, and you can find a lot of information. Yep, next one. Same slide as you've seen before. We are asking you guys to register your application so that we can keep track of it. We're still planning to add it to our website. We haven't gotten around to do it yet, but this is coming soon. And there is also this GitHub Topics feature that you can do. If you look on the Kokkos repo, you're going to see a Kokkos topic, and you can add the same label to your project, and it helps with discoverability. Next one. All right, let's get started. Next slide, please. So we had our fourth Kokkos user group meeting in May at the HPSF conference. The videos are now online. You can browse it via the agenda, and there are the slides and the recording that are uploaded. You can find all that good stuff on the HPSF YouTube channel. We will upload the slides shortly after this session, and you can click on these hyperlinks. Otherwise, I assume you can find them fairly easily if you just search on the HPSF website. And we wrote on our blog a trip report, so go and check it out. I assume you can also find some of these links on the blog post. All right, so we are happy to announce that we are going to hold our fifth Kokkos user group meeting next year. So HPSF published the save the date last week. So it's going to be April 12th through 16 in Montreal in Canada. So tentatively, it's going to be as usual, the last 2 days of the conference on Thursday and Friday, 15th and 16th. So you should already save the date in your calendars, and we will try to get call for submission mid-September. So stay tuned. Another event that's coming is we had a Kokkos tutorial accepted at Supercomputing 2026. So Supercomputing is in November, the week before Thanksgiving, 15th through 20th, in Chicago, Illinois. We don't have yet the exact date for our tutorial, but if you're interested, we're going to be giving the beginner tutorial with hands-on exercise. We're going to have some GPU access. It's going to be great. So let your colleagues know and share it and register. We anticipate we're going to add an event page on our website. We'll keep you updated on Slack. Next slide. Just reminding you to help us track the impact of Kokkos, so similar to the application gallery. So we started since 5.0, we started adding citation that you can use via Zenodo to cite Kokkos core or Kokkos kernels. And the format is as follows. So you can find all of this information how to cite Kokkos on kokkos.org on citing Kokkos. I think it's under the About tab. Yeah, please, when you publish your work and you're using Kokkos, please cite the relevant version of Kokkos and Kokkos core and Kokkos kernel that you use. We have been running now for a while a Tea Time webinar series. If you've not been able to attend till now, we have this also on the HPSF YouTube channel, so you can find sessions that you've missed. If you'd like to be invited to speak, you can reach out to Christian or to me, and yeah, find us find it on our website. It's usually the third Wednesday of the month. We try to find a compromise so that our friends from Europe and everybody in the US can attend. It's a bit rough when we're in Japan the times, but yeah, please consider joining our seminar series as well. All right, so with respect to the specific of this release, I just want to point out one specific thing. So in 5.0, we have a major removal of all the deprecated code for. We remove most of it, and we granted an extension to just few things that we had deprecated kind of late, like the memory managed alias for the memory traits, for the regular memory traits, all default, and the host mirror public type member on view. So these things are extended to next release, but they will they're still there on 5.2, but everything will be gone in 5.3. So we had warned you guys before, but now like most of it is gone. So yeah, be advised that even this last late deprecation will be gone in next release. And another important change to look forward to. So the legacy view implementation will be removed in 5.3. So the new MDSpan based view has been the default in 5.0. You can read more about it on our blog post. We've written something last year. The magic option that was letting you use the old implementation is being removed. If you have some concern or some problem with it, reach out early because this thing is going to be gone. And if there is, we were aware of some performance regression. We expect that all of them have been addressed. So if you have concern, reach out early. Thank you. And just noting that the last release of the 4X series was 4.7, and we typically give 1 year support for the latest minor release from the previous major release, and just letting you know that the extended support is now reaching its end. We had 4 patch releases, but we won't be producing more fixes. All right, Conrad, go ahead.
Okay, can y'all hear me?
Yep.
Okay. Yeah, so we'll go through some of the featured highlights for this release. So first, let's talk about the self-similar range policy interface. So Kokkos has always allowed reuse of functions on host and device. So we have this function awesome, and we give it this Kokkos inline function tag, and that allows us to either call it on host here or within this parallel for range. And that's always been allowed. But what the question is what if awesome contained parallel code itself? And so there's a few ways that you could do this. So you could have just different functions. So you could have a version of awesome that's callable on host with internal parallelism, or that's callable on device, for instance, within a team. So you'd have two separate functions, or you could have like some sort of, you can implement your own policy factory, which basically would allow you to have some execution policy, either range policy or a team vector range, um, where you could deduce which one you needed given whatever context you were in. And a similar thing to that is you could use maybe an if const expr, where you again pass in some execution, and then it picks if you're an execution space, so you're on host, then call parallel for with range policy, or if you're on device, call parallel for with team vector range. And then internally, you would have this repeated code that is maybe doing the same exact thing. There's a problem with this for both policy factory and if const expr, that you're going to get warnings. At least on CUDA, you'll get warnings about calling a host only parallel for from a host device function. So this parallel for call here with the range policy is going to complain. Even though you're not actually doing that, you'll still get these warnings that this parallel for is a host only function being called inside of this Kokkos function awesome. So what we've done in 5.2 is that we've generalized range policy to support both execution policies and team level ranges. So it's going to enable us to write generic code that we can call on both host and device. So say we have this sum views function where we pass in x and y, and we want to just sum y into x. And what we can do is we can have this other argument execution. And so if we're on host, we could call sum views with an execution space. Or if we're on device, for instance, if we're within a team policy, we can pass in team. And what range policy now will do is it will deduce where you are based on your execution and basically route your code to the correct thing without any warnings. So then you can have, this is a very simple function, but you can basically avoid repeating all of this code, having multiple versions of your function that's essentially doing the same thing. And so right now this is for range policy, but we have plans to extend this to ND range as well as to different team level calls. So like thread ranges and things like this. This is in its early stages. So for any users that are looking to use this, if you need additional functionality or things that aren't implemented, like please reach out to us and show us your use case so that we can continue to develop in a way that's useful. So next is we have these view with MD span style template arguments. So stood MD span uses a different style of template than the classic view. So the classic view here, we have our data type, layout type, memory space, and memory traits, whereas MD span has element type, extent type, layout type, and accessor type. And so the relations between these two are data type and view is maps to element type plus extent type. So you can think of data type as being you give it like double and then you let it know the rank based on how many compile time and runtime dimensions that you have. Whereas MD span, that's split into element type and then extent type. Layout type maps to layout type. And then in the classic view, memory space and memory traits together map to the MD span's accessor type. And so Kokkos views now will support the MD span compatible template parameters. And so what this right now enables us to do is now, unlike before, we can specify index types other than size t. So we can potentially have a view with a smaller memory footprint. And then this just aligns closer with the C++ standard for MD span. So some notes is that you'll need to use MD span compatible layout and accessors from Kokkos. And here's what we have so far. We have this layout left, layout right, layout stride. Again, with lowercase and with the underscores. And then we have also in the experimental namespace, we have the layout right padded, a layout left padded, and this accessor, which takes in an element type, a memory space, and memory traits. And so before, the classic view would, so for this 2D view with data type T, this is how we would write it. And then now the equivalent in the new style is you pass in T, then you give it the extents, where here we give the extents type size type, but you could have an arbitrary index type there. And then you have your layout left, and then the accessor, which also takes in T as well as the host space. And here we have the default memory traits, but you could pass in whatever memory traits you need. So there are some limitations, all of which are um, future plans for us to implement, but currently no template arguments are defaulted. So you have to explicitly list all of them. Compiler warnings exist inside Kokkos when you use signed index types. There's some view member functions that are assuming unsigned types like extent. So those need to be addressed. You can arbitrarily mix static and dynamic extents, but it's not well tested. So you're kind of on your own currently if you want to do that. But the goal is to have those fully tested. And then right now, custom layouts and accessors aren't officially supported. So there are workarounds where you can write your own layout, for instance, but it's not officially supported in Kokkos yet. So that's the MD span style templates. So next is we have this SFC64 random number generator, which it's from a 164-bit seed, you can get 2 to the 64 streams. It has a period of at least 2 to the 64, but the expected is around 2 to the 255. And the thing about this random number generator is you can now have pools which are initialized in parallel. So for large pool sizes, it can be much faster than the current random algorithms in Kokkos. And so you can have these bit reproducible distributed partitionings, and it can be used as a drop-in replacement for the previous algorithms. So our example here is we can define both pool 0 and pool 1 using the same seed, and using the seed offset for pool 0, we give it seed offset 0 and we want 500 states. And then for pool 1, we offset by 500 and then we want 500 additional states. And so what we could think about using this for is each MPI rank in a program, for instance, could have its own pool. And then with this seed offset, it can be the same results as if you had a single pool of 1,000. And so you could have a reproducible random number generator over an arbitrary number of ranks. And then once you have pool 0 and pool 1, you can use those exactly like you would use random ExerShift 64. So it allows for a distributed partitioning, unlike the current ones. We've extended MD range policy to support one-dimensional ranges. On GPU backends, we use tile size 256 as default. On host backends, we use similar chunk size logic to range policy. And then this includes support for parallel form, parallel reduce right now. But you can have a 1D. Previously, it was rank 2 was the smallest ranked MD range policy, but now we've extended that to rank 1. And then lastly, we have these convenience overload for create, mirror, view, and copy. So the old API for create, mirror, view, and copy, you always had to pass in a space and a view, and then it would return the mirror with the values from view copied in. So a problem actually arises with this is if view uses shared space and then you pass in host space, we before would actually allocate, or what currently still happens is a new view is actually allocated, even though view and mirror in that case should both be able to access the same space. And so what this overload will do is if you pass it in view, it will decide if you actually need a new allocation or not, and then avoid an unnecessary allocation, for instance, in this kind of example above. And so this actually makes create mirror view consistent with create mirror, and it simplifies view management. Thanks.
So I will take over for the general enhancements. So first thing, following the improvements to empty range that we had in the last major release, we made other improvements on device when your problem size is smaller than the total parallelism that your device provides. We can get some pretty nice improvements in some cases. So as you can see in the graph, we can reach almost or exactly native performance with our changes. And for bigger problem sizes, we don't have any difference. We have an equivalent performance as of what was in the previous release. For Kokkos SIMD, so we have some combination of APIs and data types which are not supported, and we're working on completing the support. So in this release, we added support for UINT32 for the Neon backend. We also improved the performance of the generator constructors on SV because we are doing some inefficient things in our implementation, but that should have been fixed by now. And we also made the flag argument for memory operations optional because before you had to always specify a flag if you wanted your data to be aligned or not. Now we default to a SIMD flag default, which is unaligned data, and it would make your code a bit more concise than previously. For Kokkos graph, we renamed the native graph and native graph exec methods that allow you to get the native graph to backend specific names, since those functions are about interoperability and not portability. We thought that it makes sense to have to spell out the backend name. So now you have to call CUDA heap SQL graph or CUDA heap SQL graph exec. We added support for querying the kind of a graph node. So we introduced the graph node kind enum, which gives you the type of a node, whether it be a root node, a capture node, or a kernel node, for example. This information can be queried at compile time using the node kind alias on the node type, or at runtime using the getNodeKind method. And we also now allow to access the underlying backend nodes using the node.cudaheap or SQL node method. For the atomics, we improved the performance of the load and store operations, which were based on compare and swap implementation. We now use compiler built-ins when they are available, and this can lead to pretty big performance improvements when there is a lot of contention. So as you can see in the graphs, on the left, it's on a Cray CPU, and on the right, on a Hopper GPU. So on CPU, we divide our slowdown by almost 2 by using compiler built-ins. And on device, I cannot even give you the metric because it goes out of the graph. So you should see performance improvements if you have a lot of load and store with atomics in your code. So for the miscellaneous features, we introduced the Kokkos first inline lambda macro, which allows you to hint to the compiler that Kokkos lambda should always be inlined, and it avoids you messing with compiler-specific attributes. We now support the force inline macros with MSVC. Previously, they were available, but they were just an empty attribute. Now they should have the expected behavior of telling the compiler to always inline your function. Following the support for C++ module builds with Clang that we had in previous releases, we now support building Kokkos as a module with MSVC and GCC 16. So you can find more information in the documentation, but you can access the kokkos.core module. Same for kokkos.cmd and several modules for the containers and algorithms. We introduced a new Batalog exception that is thrown when Kokkos fails to allocate some data. So this can be used to distinguish between a Kokkos allocation failure and a regular allocation failure. And we increased the maximum level of team scratch size, the maximum size of the level 1 team scratch from 20 megabytes to 8 megabytes. The rationale for this is that architectures have got more memory now that so architectures now have more memory than the architectures that were present when we decided to allow only 20 megabytes. And this limitation might evolve in the future. We also made some special methods on execution spaces no except, as well as the move constructor of views. We added new aliases to execution spaces and memory spaces, which are index type and size type. So those denote the preferred integer types, signed and unsigned, to be used for indexing and other integral operations on a specific execution space. So typically on device execution spaces, this will be 32-bit, and on host execution spaces, this will be 64-bit. We promoted the numeric traits out of the experimental namespace. So the numeric traits are an alternative to the numeric limits infrastructure. So you can query like the maximum representable value for a type, the infinity for floating types, nines, and everything like that. The versions in experimental are not yet deprecated, but they will be in the future. So please use the ones in the Kokkos namespace. And if you're still using numeric limits, please use the numeric traits. And we are now using the mathematical constant, sorry, from the standard library instead of rolling out our own, because C++20 introduces some numerical constants, and we now use them instead of hard coding constants in our code. And lastly, for the stud algorithms, we decided to align to what is done in the C++ standard and move the iterator-related functions from algorithms to core. So now if you want to use begin and cbegin, cend, or distance, you will have to include kokkoscore.hpp instead of kokkos-algorithms.hpp. And you should note that the iter_swap function is still in Kokkos algorithms. And additionally, we are now checking preconditions on views when calling stud algorithms. So this is an improvement, and yeah, that's all for the general announcements.
All right, with that, we've come to the backend updates I'm probably presenting to you. For the CUDA backend, we have a couple of things. One of them is that previously we had an explicit limit on 48 kilobyte of scratch memory, although like the newer GPUs support much more. So we fixed that so that you can actually use more on your level 0, which might help you quite a bit. The second item here is that NVCC now supports C++23 from CUDA 13.3 on, and we also support that. There was a bunch of changes we needed to make because there was some different behavior with respect to stud pair and Kokkos pair in the constructors. So you might come across that, but at least it shouldn't be a problem coming from Kokkos. On the HIP side, we mostly added architectures. So we have the Strix Halo, Radeon 860, and Radeon RX where we basically just added architecture flags. So you can use all of that. And then we were working on the static batch sizes, the previous releases a little bit, if you remember. And for the MI300A, it turns out that the deep copy path needs to use some kind of parallel 4 because it doesn't work well with the mem set. And that was the reason why we were able to get an improvement here, basically just by making sure that we are using the static batch size for running any kind of deep copy operations ourselves. On the SYCL side, there was a user request for being able to compile on Windows with SYCL. So we fixed that for OpenACC. We ran into like a race condition, which we fixed. And we also fixed stuff for HPX in particular. We were promising that if you call Kokkos finalize, that there will be an implicit fence. And that didn't work well with HPX, at least when we fixed that, at least when using the default execution space instance. The last item here is a new backend actually called Next Silicon. And so far there's not much functionality there, but there is some basic support and more to come. Then to the build system updates, we have a little bit there too. If you remember, we are checking for compiler and linker flags being usable, but in practice that turned out to be a little bit fragile, and sometimes it was giving us false positives. We decided to turn this check into a warning instead of just outright rejecting your build in the configuration step. That especially affected SYCL builds. And in the same vein, we also try to give you more information now in case this check fails. Previously, we were just saying, okay, fails, look into your CMake configure.yaml, which is not super useful. But now with at least new enough CMake, we try to print this line, and then we can see how to fix that or what the actual problem was. Another minor improvement was that NVCC wrapper can now handle response files in case you come across them. And finally, we removed the Kokkos CX extended user option, which initially was something like CMake CXX standard. And then we replaced that and deprecated it, but kept it around for a long time. But now we don't even set it anymore. And that's it for the build system changes.
Very good. Thank you. Now we move on to deprecations and breaking changes. Just before I dive into this, remember that all these changes we roll out gracefully. So all these changes, these breaking changes and deprecations will only manifest and affect your code if you set Kokkos enable deprecated code 5 to false. And remember, currently in the version 5, it is on. At some point in the future, we will set Kokkos enable deprecated code 5 to off per default. And then at some point later in time, we will start removing that code. So just so you are aware on how these deprecations and breaking changes could affect your code. We have deprecations and breaking changes in two categories. One category is in the namespaces, and the other one is related to views. In the namespace category, we deprecated the HIP and SYCL namespace aliases in the experimental namespace. So we kept it potentially as an oversight, relatively long as an alias in the experimental namespace. This is now gone, and please use Kokkos HIP or Kokkos SYCL in the Kokkos namespace itself. We also deprecated the out-of-rank view extent queries in order to align with MDSpan. So previously, if you had a view of a certain rank, you were allowed to query all the dimensions of your views, even expanding beyond the rank of that view. And now the APIs extend, and then static extend will error out if you are querying for a dimension that exceeds the rank. And this is shown here in the example. Imagine you allocate a view, a two-dimensional view of size 10 by 20. Then you can query the extend in the dimension 0 and in the dimension 1, which will return the extents, but we will error out if you are querying any dimension beyond that extent. Next slide, please. Further, regarding views, we have two breaking changes. So now deep copy the behavior of deep copy has changed. If deep copy receives an equal or identical C++ object, then we will error out with the precondition violation. This was a no-op before, but it is potentially a source of errors. So be aware of that. You still can use aliases to allocations, which will trigger a deep copy. But if the object is identical in C++ terms, then we will error out. And the last thing is we have made is assignable stricter. So now if you are trying to query the property is assignable over onto views, now we correctly identify or take into account the constness, so the CV qualification of a view, and error out or give you, in this case, a false value if the left-hand argument of is assignable is const qualified. And I think with this, we conclude the breaking changes and deprecations.
All right, next up are bug fixes. This is going to be quick. So this is just a subset of the bug fixes, but I'm not going to bore you with all of them. So these are the most interesting ones. So there were a bunch of them that were concerning SIMD. We had some places where you called host-only functions on device. If you ran into this, you probably already know because your compiler was spewing messages at you. We also had an ambiguous function call in the masked versions of SIMD reduces that you also should have noted if you ran into this. And there were some seg faults if you do unaligned store. So the default would be or was an aligned store. If you do an unaligned on AVX512, it would just seg fault. This is fixed now. And we found some failures that we were able to fix with Clang, mainly Apple Clang 14 and Clang 14 and 15 regarding the SIMD implementation in Kokkos. Next slide. Okay. Apart from that, we were using atomic max and atomic min fetch from the GCC implementation when you were compiling with LLVM. But some of these are like icing your compiler, so we had to guard them for the LLVM version that they actually became fully supported in, which is 22.1. That's another one that if you ran into this, you already know. We had a performance regression on HIP with range policy if your static batch size was 1. We were doing some unnecessary computing of bounds and checking that are for static batch size of 1 are just not necessary. We fixed that. Previously, if you were compiling for RISC-V, if you are in a situation like that, we had some special treatment for GCC because we in Kokkos support some GCC versions that some minimal versions that don't support RISC-V, but these things were also triggering for Clang, but Clang basically supports RISC-V. So this is fixed. You should be able to use this combination now. We had some very subtle issues if you had parallel scans in the same execution space, like multiple of them, and you were resizing the shared memory between them basically be running, which was if one is still running and you resize the shared memory and the other one already starts, then you would basically yank the shared memory underneath the kernels. So that was concerning CUDA. It is fixed now. If you ran into this, if you saw some very weird behavior with respect to that, it should be fixed. Previously, you could allocate a view and then go and say, okay, from this view, I want to do an unmanaged version of a subview. And this was working. We messed this up with the transition to Vue implementation and is fixed now, you can again use this, which should be absolutely legal. That's why it's a bug fix. And finally, we had a misunderstanding in unordered map. If you use it as a set, basically meaning you have a void as your value type, we were basically having some if conditions that were exactly doing the opposite of what they should do. This is also fixed now. But that's all the bug fixes that are really important. The rest is hopefully something you never ran into in the first place.
Yes, very good. Thank you. Next topic is Kokkos tools. So many of you might have heard about Kokkos tools. It is an important thing, especially for profiling, debugging, and connecting external profiling and debugging tools to your Kokkos application. And we are happy to announce that we have released Kokkos tools in the version 5.2. We just released it yesterday, so it's hot out of the oven. So feel free to check it out. Two noteworthy things that I wanted to share with you today. So first of all, we are aligning the release cycle of the Kokkos tools with Kokkos Core. That means we are shipping Kokkos Core 5.2, and this coincides also with Kokkos tools 5.2. As a reminder, it is a relatively lightweight profiling and debugging library that you can use with your Kokkos applications. The nice thing is that you don't need to recompile or enable tool support in your existing compiled binary. Rather, you can simply use LD preload and rely on that and configure it via providing these Kokkos tools libs environment variable. So setting, pointing this Kokkos tools libs and variable to one of these tools libraries that we provide, or by running your application with Kokkos tools libs execution flag. What we do internally is when we run a Kokkos application, we check if any callbacks are registered and then use these callbacks depending what tools have been provided via these environment variables. Quick note, so Kokkos tools use CMake, so you can use CMake to build and configure and build the project. You will require some C++20 compatible compiler, but that should be fine. We have a documentation for it that lives here on this wiki page. And of course, there is this repo, so feel free to check it out. And then the next slide, please. I wanted to comment what the current status of Kokkos tools is. So within HPSF and the Kokkos ecosystem, Kokkos tools is a maturing in a maturing stage. And this means that it is functional, it has users, it is well maintained, but there are a couple of things that require improvement. For example, the testing capability that we are using right now is not really sufficient. Or for example, a deprecation cycle via things like, Kokkos enable deprecated code version number is not implemented yet. So we are working toward these things. We are ramping up testing and CI coverage. We have a bunch of tests included. We test some combination of backend and unit tests to compile and at least to run some of this. We have also explored to what degree we can support a full-scale production software like LAMPS. So we did a sanity check, and we have to say, yes, we throughout the tool range that we have, we were successfully able to run Kokkos tools on LAMPS, for example. So we are working on maturing this project. Feel free to check it out. We will be releasing this in conjunction with the Kokkos Core release cycle. Next slide. Okay, I think this. Oh yeah, I'm handing back over to you.
Thank you, Jan. We are running a bit late. We're gonna now go over to the Kokkos kernels presentation. While Luc shares, do we have any question? All right, then since Luxi is ready, he's going to go over his presentation and we'll reserve some time at the end if you have questions that you didn't get a chance to ask. Luke, go ahead.
All right, I'll run through the Kokkos kernels 5.2 release briefing. So this was, of course, as usual, a shared work of the whole Kokkos kernels team. Oh, come on, why can't I go to the next slide? All right, so we're going to go over some new features, general enhancements, some changes to the benchmarks, a few deprecation and other breaking change, bug fixes, and I believe a bit of documentation. The usual resources are available. Feel free to ask any Kokkos kernels related specifically on the Slack space for Kokkos with the Kokkos kernels channel. That's probably where you would get the fastest answer. Let's go over some new features. So we've continued after the introduction of the GEQRF to decompose matrices in 5.1. We are adding the GEMQR, which allows you to apply the Q factor to a vector or matrix. You'll have the usual options to do it on the left, on the right, with transpose or not. This is typically done when you want to do something like a solve and want to follow it up with a triangular solve on R. If you require the calculation of the Q factor itself, then you can use GQR. And we also are adding support for Cholesky decomposition with the following POTRF and POTRS. The functions are almost identical to the APIs of LMPAC, except for the most of the arguments related to view sizes being skipped since the view carried them along. Some new kernels for the batch dense area. So we have this scaled L2 norm computation. We have some serial team and team vector implementation of the rotations, their application for both givens and modified givens rotations. We've added some batch swap capabilities and some batched norm support for L1, L2, and L infinite norms. There is some subtle discussions around the implementation of these norms. So if you have more questions on this, feel free to reach out. And some new implementation for variants of IMAX that support team and team vector policies. Most of this work was carried by Yuichi, by the way. We have some support now in the sparse area for the conjugate mode when you want to transpose a sparse matrix. So here is the function call, transpose matrix, and by default, the conjugate values flag is false. So you recover the usual behavior if you do nothing. But if you want to conjugate, you cannot do that explicitly. It saves a good amount of time compared to the previous approach, which was first transpose, then launch a second kernel to conjugate. And we've added some merge path algorithm for load balancing. You can use that in Kokkos sparse merge. This was actually some prior work done by Carl that he kind of cleaned up and merged, and the transpose matrix was a contribution from Christian Gluza. Okay, some general enhancements. For the build system, we now always turn on the instantiation of memspace host space by default. You can still turn it off, but by default it's turned on. We've found that it's more expected, that it makes more sense, and that it leads to better ETI in general. So again, you can turn it off if you explicitly don't want the host space to be instantiated. We haven't found that to be the case for most people. So yeah, let us know if you have any feedback on that. we are adding conjugate transpose modes for the following kernels. So the team gem, team vector gem, and serial triangular solve in the batch realms. For BLAS, we've refactored the unification layer of AX plus beta Y, alpha AX plus beta Y. And so most importantly, it avoids some deep copies. So in all cases, so it is cleaner, it's non-blocking again. Yeah, we very much like it. We've done some updates in the QSparse TPL path for sparse metric product to support the QSparse SPMV preprocess unless you are requiring the fast setup option. Yeah, so unless you require fast setup, it's going to be the new default for QSparse code path. The benchmark area, so we've added significant amount of coverage in the BLAS1 benchmark with the following addition. So basically, I believe all of BLAS1 is now benchmarked. So AXP, AXPBY, scale, swap, norms, etc. And we already had support for that product and other things. So yeah, I think it's a worthy additions, and we'll continue that, looking at expanding our support for BLAS2 benchmark. Okay, deprecations. We're removing inner product space traits from old headers and namespaces that were Kokkos named, which is not very appropriate since they are living in Kokkos kernels. So if you used to include Kokkos inner product space trait, sorry, please now switch to Kokkos kernels inner product space traits, and you will get some deprecation warning regarding the Kokkos details inner product space traits. So please do use the Kokkos kernels namespace instead moving forward. Some bug fixes now. It was reported that Kokkos BLAS scal, which is called in Kokkos BLAS gem when either A is has a dimension that's 0, the inner dimension k, or the same thing for B, then you only scale the C matrix by doing C equal beta C. And it was missing an execution space instance, which meant that this call was not respecting the resource allocation from the user. So we got that fixed. Graph coarsening team policy is now using vector length max to make sure that it doesn't exceed the max support. It used to be hard-coded to values that were not correct and were not respected in Kokkos core because they were just too large. So it's a good cleanup. Our householder reflector computation now uses some math function overload for Staccato types, so it will allow Staccato builds to be passing again. We are removing some calls to the rend function in favor of the C++ standard one that basically allows for better Windows support. This used to create some issues in these builds. And the Kokkos sparse SPGem handle constructor will no longer overwrite SPGem default. There was a bug that we introduced where that would prevent you from getting the exact version of the algorithms you wanted. Our logic was a little wrong. And so that is now fixed. It also fixes performance regression that was observed in some cases. Okay, and finally, some documentation updates. So multiple new API documentation examples in batch dance. So here are all the glorious new documentation pages and examples you can expect to have access to. So dot, norm, the rotations, swap, scale, and IMX. The examples are going to be in example wiki or example docs. In a future release, we're going to move and consolidate the location to be example/docs, since we moved from the wiki base to the internal documentation in previous release. And that's it for Kokkos kernels. If you have any question, let me know.
Thank you, Luke. All right, we're just at time. Sorry, we started a bit late. We're going to stick around. If you have questions, feel free to unmute yourself and ask. Otherwise, thank you and see you online.